Right team, get excited. We're going to move into bivariate data now. So I've looked at univariate data like one variable, so now we're looking at bivariate data like two variables, which is what we do most of in further maths. The good thing about that is we can compare two variables. So now that we have two, we're going to move into a lot of like those reports that we looked at, and we're getting good at them, so that's fine. So our first is the two-way frequency table, and as you can see, there's obviously two things. There's the independent variable here, and there's the dependent variable here. So that's the IV and the DV. So you can see our independent variable here is gender, so male and female. Our dependent variable is view, so for and against. So just a few things to note. You have to include the totals down the bottom. So here I've got the totals of these two gender columns and the totals of the two view columns. So all the totals and then a final total. You can't just write this data, you have to have all the totals listed as well. So I've just written here the independent variable is on the horizontal and the dependent variable is on the vertical. We'll go over that a bit more later on. And you have to label the variables. So I've labelled them here, gender and view. You don't have to label them IV, DV, but you do have to label them with what they are, gender and view. Similar to that is the percentage two-way frequency table. So here we've changed all of these pieces of data into percentages. So I haven't done that by adding them all up out of 50. I've totaled them up for each of what they're out of in the independent variable. So my first independent variable is males, so 6 out of 25 males was 24%. So I did that here, convert all those using the independent variable totals. 6 males out of a total of 25 males. So 6 out of 25 times 100 is 24%. So that's how you convert it to a percentage in your calculator. Same thing, say we wanted to do the females. There's 13 out of the 25 females this was a gun control survey. So 13 out of 25 females is 13 divided by 25 times 100, so 52%. So I've done that for these other two as well. 12 out of 25, which was 48%, and 19 out of 25, which is 76%. So in a percentage two-way frequency table, you can see that my totals, all the independent variable totals, should total 100%. So these two here equal this 100%, these two here equal this 100%. So we no longer have to have totals all the way around the outside, we're just totaling the independent variables, in this case the gender. So always, two-way frequency tables have totals for all directions. Percentage two-way frequency tables, you just need to have the 100% in each of those columns and change all the pieces of data to 100%. Secondly, here's some more information about two-way frequency tables. Only totals for the independent variable, I've told you that already, not the dependent variable. All the totals have to equal 100%, and we still have to label the variables. We'll get some practice with them, so that'll be fine. Second thing, we're also going to think about whether the two variables are actually related to each other, like whether they're affecting each other, or if they're not. So, if the two variables have different kinds of data results, we can say that they are related. So I've written that here. Similar statistics, so if there's not much difference, then they're not related. But if the statistics are different, then we can see there is a relationship between the two variables. Here's some examples. So here, hair colour and your intelligence or your IQ. So we can see here that people with red hair, 98% are geniuses, but only 2% of people with red hair are not geniuses or normal. So let's check if that's the same sort of percentages for people that don't have red hair. Only 0.01% of people that don't have red hair are geniuses, and 99.99% of people that don't have red hair aren't geniuses. So if they weren't related, we would expect these to read the same and these to read the same, but they're very different. So I can see here these two that I put in pink are clearly different, and these are also clearly different. So the two variables are related or associated. So we're not saying, do the numbers look the same, are they related? We're saying, is this hair colour and this IQ, is there a relationship between them? And we're saying yes. So there's a big difference between what hair colour you have and what IQ you're going to end up having. So the two variables are related. One depends on the other happening. Let's look at another example. Here, facial hair and awesomeness. So you can see here, these two are very different again, and these two are very different again. So we would say that facial hair and awesomeness are related or associated. So they're the words we're going to use. They're either going to be related, or if you want to say associated, you can, or not related or not associated. So I've chosen to go with the words related and not related, but you could go with associated if you would like to, but I reckon related is easier. Let's look at another example of two variables that aren't related. You can see here that your career and your favourite food, like, it makes sense that they're probably not related, and let's check the data. So 74% of people that are teaching, their favourite food is pasta, and 76% of people that are firemen, their favourite food is also pasta. So it doesn't really matter what career you are, pretty much the same percent, or they're pretty close, have the same favourite food to be pasta. So we're saying they're not related because it doesn't matter what career you're doing, your favourite food's probably going to be about the same. So they're so similar, or quite similar, that they're not related or not associated. So here's another example. Teachers, 26% said their favourite food was curry, and firemen, 24%, pretty much the same, said their favourite food was curry as well. So it doesn't matter what career, their favourite food is still going to be the same. So those two variables aren't related. Doesn't matter what happens, it's not affecting the other one. So here's a sample report for this one here. The figures regarding career and favourite food are very similar, and I've included the actual data. Therefore, they are not related, and that's my conclusion. So you have to include your actual data and your conclusion. Other than that, that's all pretty good.